Okay, most people seem to have trouble with the second page of domain and range. But just to make sure, I'm going to ask about anything from 147 to 148. So, of course, everybody who had trouble with the second page of domain and range should be asking me about questions on 148, since there are curved lines on there. But there's no real need, because I'm about to go over it anyway. No one? Pardon me? 150, number 2. All right. So, as always, domain I do in blue, range I do in red. Domain is the set of what values? Not quite. Domains are the set of the independent variable, and the independent variable is usually graphed on the x-axis. Don't make that mistake. If I go back in the video, I can find the spot where I say usually. And if I go back in the notes, I will find where I said domain is the set of the independent variable. So since I'm only looking at domain right now, I'm only looking at the independent variable, which is usually graphed on the x-axis. So I'm only going to look at the x-axis, which is right here. I start at the lowest point. There it is. I have a graph covering with an x value all the way to there. Now, that photocopies poorly. If you said it's an open dot, fine. If you said it's a closed dot, fine. It doesn't matter. I don't care, because it's photocopied so badly. It doesn't matter what you put. That's not what this question's about. The question is about whether or not you can find a domain. What is, again, the lowest value that we have an x piece of data for? Negative 1, 2, 3, 4, 5. That is definitely a closed dot. So it is negative 5 less than or equal to x. What does that mean? Negative 5 is lower than or equal to every x value I have. And every x value I have must be less than 0 or equal to 0, depending on whether you thought that was a closed dot or not. Again, I don't care if you thought it was a closed dot or not. That's not what's important. What's important is you recognize that you are only looking at values on the x-axis. And because it is a line and the x-axis has been shaded in, all of those values have x values, including all the decimals. Then I can write this as an interval, which would be negative 5. And again, depending on whether you say that's a closed dot or not, I said it was a closed dot, so I said equal. You get the square bracket. Range I look at with red, usually. Range goes now on the y values. I go from the lowest y value I have to the highest y value I have. Now, a great many kids do this. They find the lowest, no problem. Right there. And then they make this mistake. They go to the end of the line and they stop there. Is that right? Of course not, because all of this is a y value, isn't it? So I have to look at the y values, which go from there up to there. And again, you start with the lowest, which is negative 1, less than or equal to y, less than or equal to 1, 2, 3, 4. And again, since I have colored part of the axis, I am able to do an interval. Negative 1, 4. And of course, if you said that last dot was closed, then this is gone, this is gone, and this becomes a round bracket. Okay? Now, sometimes you guys make this argument. You're like, well, okay, I get it, fine. And then we come to another question, and then all of a sudden you don't get it anymore. I do not understand that. I have tried to be nice about it. I've tried to be funny about it. I have tried to be, my good gravy, how can you not understand that? I'm out of reactions to have. Okay? If you don't understand number 2 right now, I expect to see you at lunchtime. And if you do understand number 2 right now, then you can now do every domain and range question that you are ever given, because they are all exactly the same. Okay? You need to make that decision, because I cannot chase down 120 of you. And I cannot read your minds. Okay? I'm going to do one more. I'm just going to do it. I've done all the explanation I can possibly do. It is up to you to learn this. There is no other way to explain it. But I will ask for a request for any number from this page for which I use to do my last example of this. Sure. So 4, again, you have to be aware that that is a closed open dot. That's an open dot. That's an open dot. If you didn't make them open dots, that's okay. Again, I can fix that as well. But they came out pretty well, these ones. So again, domain, I check the X's. What does that arrow mean? Keeps going in what direction? Same direction. For how long? Ever. So if that line is going to go that way forever, am I going to have an X value forever going that way? Excellent. Now, this line covers me to here, yes? What happens right there? The line keeps going. What happens right there? The line keeps going. What happens right there? The line keeps going till I get to this arrow. What does that arrow mean? It keeps going forever, which means the entire x-axis is shaded, yes? Which means x goes from what to what? What is the lowest number I can possibly have? I'll change it around. What's the highest number I can possibly have? Buzz Lightyear is often seeking it. Infinity. Yes. So the lowest number I can possibly have is negative infinity. So there's a lot of ways to write this. You can write negative infinity less than. Can I put equals to negative infinity? If I start walking, will I ever get to infinity steps? No. So I can't have equals x less than infinity. I could also write this, x, and then this is something I haven't shown you because it's not important to grade 10, but we use this big funny E in math class. And it just means is a set. X is a set of real numbers because every single real number ever is a value of x according to this graph. That's another way to write it. Another way to write it, negative infinity, positive infinity with round brackets. Okay? Now, I'm going to look at the y values and y values only. So I'm done with the x. Now, where do I have a y value? Well, I've got one right there. I've got one right there. I've got one right there. And I've got one right there. Have I colored in any part of the y-axis? No. So I cannot use any of this notation because I have no intervals. I have no part of the y-axis. I only have specific points. So I have to do the squiggly brackets. And it is negative 3, 0, 1, 2, 3, and 4. And that's the only way I can do that because I only have 4 values of y. There are no other values of y. If I ask you what is the x value when y is 7, is there one? No, because if I go up to 7, 5, 6, 7, there's 7. And you can see I have no inputs when my output is 7. All right? This is the end of the teaching part of grade 10 on domain and range. It's going to become much bigger deal in Science 10, if you haven't already taken Science 10. It's going to become a much bigger deal in the physics part of Science 10. And it's going to become a much bigger deal in Physics 11, Chemistry 11, Precalculus 11, Foundations of Math 11. But as of now, this is where you need to be. If you don't get it, you need to come and see me so you can tell me one-on-one what it is you don't get. Because I don't know how else to talk about domains and ranges. Okay? All right. Please turn your page over to page 151. All of you are able to do this first page already. You do not need me. But we're going to go through it. Let's go. Start with the first one. Now, since you have a graph here, you have a hint as to which is the independent and the dependent variable, yes? Because I told you that 99% of the time, the independent variable is graphed on which axis? The x-axis. So when you look at this graph, you look at the x-axis, you see that time is on the x-axis. Which means your first guess is to say time is the independent variable. Now, you've had some other hints about that too. I've also said that time is almost always the independent variable, isn't it? Why? Because is what you say when you don't have an answer. Why is time the independent variable? Are you guys scuba diving right now? No. So is your depth below the ocean depending on how much time is passing? Or is you being under the ocean affecting the passage of time? Are you under the ocean right now? So can the depth be the independent variable? No, because you are not under the ocean. Okay? We are above the ocean, and yet time is continuing to pass for us, isn't it? Yeah. Could we graph our depth under the ocean against time right now? Yes, we can, because we are not going under the ocean, are we? Okay, Jordan, how can I want to understand. Right now, start a stopwatch. Okay, pretend you have just gone click. Is time passing? Excellent. Are you under the ocean? No. So your depth is 0, yes? Is time still passing? Yeah. Excellent. We've now talked for about a minute, haven't we? Has your depth changed? No. So your depth is 0 and we've gone a minute. Picking it up? Excellent. At the end of this block, or 28 minutes from right now, will you have gone under the ocean? Will 28 minutes have passed? So will your graph, is your graph possible? Yes, you can graph this because you went 0 meters under the ocean in 28 minutes. Do you understand? Excellent. Meanwhile, the person that did go under the ocean, the longer they were in the water, the more chance they had to go up or down in depth. Yes? That is why time is the independent variable. Okay? So, the div is time, which means the dv is depth. All right? Now remember, the hint is that time is often the independent variable because time is passing for everybody, right?
Yes.
Okay. How many minutes did the dive last? Now you guys should be able to do the rest of this without me. Look closely. I have done things on this to cause you grief. So if you must, or if you need to, talk to your neighbor to tell me how many minutes this person was diving.
30.
It is indeed 30 minutes. Well done, Daniel. Why is it 30 minutes? I've only gone one step past 28.
Because it increases by 2.
Because it goes up by 2. Scale matters. All right? Now, at a couple of times, the diver stopped her descent. When was that? When did she stop swimming downwards? She saw Dory, and then she saw Crush, the turtle. When did those two things happen?
At 4 minutes and at 8 minutes.
So from 4 minutes to 8 minutes.
And then from 10 to 14.
10 to 14 minutes. How did you know that?
Because I looked at the graph and it went up and down.
The graph went up and down. That's how you know she wasn't going deeper?
Yeah.
Because the graph went up and down?
Because it was flat and I went to 4.
It went flat. There you go. Excellent. It went flat. Her depth did not change. But what continued to pass?
Time.
Time. Why?
Because time never stops.
Because time is the independent variable and it never stops. What is the other value that you cannot have for time? Could this graph go like this?
No.
No. Why? Because time doesn't go backwards unless you have a 1985 DeLorean powered by plutonium and a flux capacitor, which none of you do. If you didn't get that joke, all 3 Back to the Futures are on Netflix right now. Go and watch them. All 3. Plus the documentary about it 30 years later, which is almost as good as the movies. It's actually better than Back to the Future 2 because Back to the Future 2 was garbage. But 1 and 3 were really, really good. So, how did you know, Daniel?
How did I know? Oh, because it went flat.
Yes. The line flattened. What did that mean? Time passed, but depth didn't. Depth stayed. Because, of course, time doesn't stop. What is the greatest depth achieved? 20 meters. Now there's a problem here. Where in the real world did she go when she jumped off that boat? No. She went into the ocean. And if we watched her jump into the ocean, where would we say direction-wise she was going? Down into the depths of the ocean, yes? But the graph went in what direction? Up, because her depth was increasing. Do you understand? The graph is not a drawing of what happened. Do you understand what I am speaking of? The graph shows the data. What really happened would have been this. Ocean, boat, person. Wait.
Is there a shark?
No. What really happened is she went, did she go on an angle downwards? No. She probably went, whoop. And then what did she do there? She took a break, took a rest. There, that's where she saw Dory. Then she went, whoop, down to 20. And down there, she saw Crush. See, he should have been green. I realize this now. Shut up. You guys can't draw turtles. There. Crush. The graph does not draw life. The graph shows data. Understand the difference. How long did she spend at the depth of 20 meters? How long? 4 minutes. Oh! I got Crush's leg here. 4 minutes. And since she's underwater, I'm drawing in blue. What is the domain and range? This is a little bit tricky. I don't got you because you know how to do this. I haven't fooled anybody because we just went over this. Somebody out of the 30 of you can read the domain of this graph. I'm going to wait patiently and sip my coffee while the silence starts to become uncomfortable. Haley. The domain is 0 less than or equal to. Now, what should I put here? X? Time would be better, right? Because we're actually measuring something this time. Okay? But X is cool. Time. And then? Nice. I like the way you think, Haley. Perfect. What's the range? 0. Less than or equal to y, or depth, because we're actually measuring something. Depth. Forgot the T. I just have depth. Depth. No, Johnny Depp spells it differently. 20. All right. Nice job, Haley and Jordan, and everybody else who didn't say anything.
I said Johnny Depp.
Okay. All right, we're moving. Yeah. Okay. Now, look at number 2. Number 2 is slightly different. Does the graph tell me anything about what happened?
Water went in and then water went out.
Does the graph tell me that?
Kind of. Oh, I know. Yeah, it's like there's 1 liter and then it goes up.
Absolutely, the graph tells me that. Yes, excellent. The graph tells me that there was some water in the watering can, and then as time passed, there was more water in the watering can, and then for a while, there was no change in the water in the watering can, and then all of a sudden, the water poured out of the watering can, yes?
Yeah.
That's what the graph tells us. Is that what happened in real life?
Yes.
Possibly. Could anything else have happened?
Somebody could have dumped it.
Somebody could have dumped it. A mule could have kicked it over.
Yeah.
I could have filled it up with cold water and run down the beach over all the people lying there, sun tanning. I could have done that, yes?
Yeah.
Picking up what I'm putting down? The graph only gives you data. It doesn't tell you what happened. Now, is this an English class? No. So will I mark you on how interesting your scenario is when you write this?
Water go in,
No.
water go out.
Now, Daniel has effectively explained what happened, yes? Some water went in, then some water went out.
Water go in, water go out.
Water go in, water go out. On the 1 to 4 scale, has Daniel minimally met my expectations? No, I lie. Has Daniel approached my expectations, minimally met my expectations, or exceeded my expectations? From a mathematical standpoint, what do you think? 1, 2, 3, or 4? And I'm not trying to put you down. I'm going somewhere with this.
Okay. I'm going with 4. I'm proud of myself.
Okay, so it, of course, is a 1, isn't it? Because did Daniel explain to me all the information offered by this graph? No, by no means. Because what does this tell me right here? It was half full, right?
Yeah.
Okay, and what does this tell me right here? It's filling up. Is it filling up quickly or slowly? Can you even answer that question? No, because you have nothing to compare it to, yes? Okay. What is happening in this part? From B to C. So what is happening? Time is passing and nothing is happening to the water in the watering can. Right? So for 30 to 70, for 40 seconds, nothing happens. To the water. Is something happening? Probably.
Oh, somebody's picking it up to dump it.
There you go. Already you've gone from a 1 to a 2. Look at you. Woo! Up top, big stuff. All right. Now, what happens from C to D? The water gets dumped out. Now, can you answer me this question? Does the water dump out quickly or slowly? Quickly. Again, quickly compared to what? How fast you filled it. Because when you filled it, you only put in 3/4 of a liter, yes? And it took you 30 seconds. But when you dumped it, you dumped out 1 3/4 of a liter in 20 seconds. Does everybody understand? So the scenario, I'm not going to write that for you. But to minimally meet expectations, A to B, we filled it from 1 liter to 1.75 liters in 30 seconds. Right? From B to C, the volume didn't change. And from C to D, we drained 1.75 liters in 20 seconds. That's pushing the 3 and 4. Does everybody understand? Does everybody see why this is a 3 or a 4 and why water in, water out is a 1?
Yeah.
And I'm not putting you down. I'm trying to get you guys to see the way assessment is going for you. Before you leave school, that 1, 2, 3, 4 is going to be much more prevalent in your high school lives. Okay? Is everybody with me? Did Daniel answer the question? Yes, absolutely he did. Did Daniel answer the question as well as it could have been answered? No. Does everybody see the difference? Okay. Now, the question becomes this part right here. I went up 0.75 of a liter in 30 seconds. Yes? It'll show up in a sec. There we go. So what happened there? I went up 0.75 liters per 30 seconds. Is that something that you have seen somewhere else in the world? Something compared to a time. Where? Driving, kilometers per hour, yes? Typing, words per minute, yes? Everybody with me? So this gave me a rate, didn't it? Now, is that a rate we would ever actually use? Do we say kilometers per half hour? No. Do we say kilometers per third of an hour? No. We try to keep our rates in singles, right? So what could I do here? I don't need 0.75 liters per 30 seconds. What would be a better rate to have there? Emma. That's a terrific one. This is 1.5 liters per minute. Does everybody understand what is happening here? Could you give me the seconds? Could you tell me how many liters per second? Emma, how did you tell me how many liters per minute? What did you do? Right, you would take the 0.75 and divide it by 30. Everybody cool? Could you tell me how many liters per hour? What would you do to the 1.5 per minute? What would you do? Multiply by 60. It would be 90 liters per hour. Everybody cool? Excellent. What is the drainage rate? This was the fill rate. What was the drainage rate? How much did we pour out? Oh, I shouldn't use gray. It doesn't really work on the gray graph, idiot. Not you, me. And now I won't change colors. So while we're waiting for my computer to change colors, you guys, there we go. I dropped how far? 1.75 liters in how much time? 60, 70, 80, 90 in 20 seconds, yes? Is that a good rate? What's weird about it? 20 seconds. We wouldn't do that, would we? So, what would be a better rate? If we're going to go to minutes, what are we going to do with this? Times by 3. So what would we do with that? Times by 3, right? Which would be 5.25 per minute. Is everybody cool with that? That is what is called, it's got other names, but at this point in our math exploration, we are calling that a rate of change. And I want you to highlight it, put a Mrs. Bad Crumble star around it, do something because it's important. And the rate of change is simply the change in IV divided by the change in dV. And that's what we did. We dropped 1.75 and we went up 20 seconds right there. Everybody cool? Now, to be perfectly accurate, what should be right there and right there? in that box, and that box. What should I put to be perfectly accurate? I should put a plus where? In with the green or with the blue?
With the green.
With the green. Why?
Because you're adding water.
Because water go in.
Yeah, water go in.
Right?
Yeah.
What should I put here?
Water go out. Yeah, water goes.
No. That won't fit. Water. No, it won't fit.
It is subtraction.
Right. Minus. Because
Water's going out.
water go out. Everybody good?
Yeah.
What the hell? It's not Daniel's. It's white, so it must be mine. No, it's not my dog. My dog's blonde. Everybody good?
Yeah.
All right, now you guys are going to, honestly, we're going to see if you are really good. Now listen to me. Some of you still refuse to do your notes in pencil. So, here is what I want you to do. If you do not have a pencil, I want you to make 2 graphs here. Okay, you're going to put yours here, and then I'm going to draw one here. This is going to be teach.
Wait, that's if you don't have a pencil.
If you don't have a pencil. If you have a pencil, you can just go ahead and use this whole thing. Because if you make a mistake, you can erase it.
Gotcha.
Okay? Everybody good? Now, I want you to draw me a distance versus time graph to show this scenario in order. Okay? Will it be perfect? No. Will we be able to make little changes to it after we discuss it? Yes. But I want to see what happens when you guys try it. Okay? You can talk to your neighbor. You don't have to do this independently. Go. That's okay. The important stuff is now. Somebody's going to be a wise ass here. How tall am I? 4'7". Right, okay. I get the joke. I'm short. My height, okay, is that a scalar or a vector, do you think? It is a scalar because my height is just this distance, yes? If I lie on my side, it's the same thing, yeah? Everybody with me? Okay. If I were underwater or upside down, I would still have the same height, yeah? Everybody cool? Okay. Now, a vector has a magnitude, which is an amount, and this just has, this just has a magnitude, which is an amount. This has a magnitude and a direction. Is everybody cool? So what we get is this. Distance is a total. Just how far you traveled. Your car measures that. When somebody asks what's the mileage on your car, they want to know how far your car has traveled. Doesn't care about what direction, doesn't care about anything, just how far it's traveled. That's distance. Displacement has a direction. I forgot the I. A direction. And the direction is always on a graph. What are the only directions we can do in math? Nope. Nope. Oh, you're closer with side to side. Positive and negative. Okay? That's the only directions we can do in math, right? If it's time, on the x-axis, it's left and right. If it's distance, on the y-axis, it's up and down, yes? But we have some rules about this. Positive in math and on a graph in reality is north, up, right, away. If you move away from a starting point. Everybody with me? I can't. I'm trying to think of some others. Up, right, away. That's pretty good. So what then is negative? Oh, I know one I missed. West. What is negative? South, down, left, towards, east. So let me give you an example. From your guys' perspective, how far did I displace myself? Now, 2 steps left. So is that positive or negative 2? Negative 2. Everybody with me? Okay. Now how far did I displace myself? 2 steps west, which is positive 2. So what is my total displacement? 0, because I am back at my starting point. Do you understand? How far did I travel? 1, 2, 3, 4. Got it? Does everybody understand the difference between displacement and distance? Yeah, it's a lot of D's. It would be tough if I had a lisp. I've always thought it unfair that the word lisp is impossible to say if you have a lisp. It doesn't seem right. Is everybody cool? All right, now there's a couple of rules about these graphs. Could there ever be a vertical line? Straight up and down, yes or no? In one of these graphs? No, why? Time never stops. Could there ever be a line moving to the left? No, because time only goes forward. Could there ever be, can you think of an example of when the line might go, this line might go negative? Is this a possibility?
When you go back, reverse.
Not reverse, but you're on the right track. If I go where, Emma? Further past my home. Okay, everybody cool? So if you were graphing my displacement here, 2 positive in 2 seconds, 2 negative in 2 seconds, I'm back at 0, and then 2 more negative, so the graph would have to look like this. 2 positive, 2 negative, and then further past 0. Is everybody good?
Yep.
All right. And don't worry, I know today is taking a long time. I'm not giving you any work. Okay, so state what happens in Alicia's race. Now look closely. Is this a distance time graph? No. Do the graph rules still apply? Yes. So look closely at this, see if you can figure it out. Talk to your neighbor if you need to. Yes. 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 No. It's not a distance time graph. Speed time graph.
Gotcha.
So what is happening to her speed in the first 2 seconds?
She went fast.
She gets up to full speed. Then what does she do for the next 10
She
seconds?
stays at that speed.
Stays at top speed. Then what happened right at B?
End of the race.
She gets to the end of the race and slows down. Does she stop?
Yes.
Yes, but she slows down first. That's why the line doesn't go straight downwards. She didn't run into a wall.
Yeah, it's like
right? And even if she ran into a wall, there would still be a very slight.
Yeah, because she tried to slow down, but she couldn't.
Exactly.
She died.
All right, so what happens from O, which is the origin, to A? What is Alicia doing? Speeding up. She speeds up to a top speed of what?
8 miles per second. No,
Of
meters per second.
8 miles per second?
8 meters per second.
8 meters per second.
She's real fast.
She is so fast! Holy, she's already gone. Speeds up to a top sped, I missed the knee, top sped of 8 meters per second in 2 seconds. Yes? What happens from A to B? She maintains top speed till what? For how long? For how long? She gets up to top speed in 2 seconds till 14 for 12 seconds. And from B to C, what is she doing? Slows to a stop in how long? 2 seconds. Is everybody cool? All right. I'm kind of a liar.
Oh no.
Just page 153.
That's okay.
It's only 4 graphs. And they only have to be sketched. They can look just like that first one we did.
Alrighty.
Way. You'll be okay.
I'm smart. I got this.
Page 153, 4 sketched graphs. Now, guys, I'm going to warn you, please, please, please sketch them on the left in case they're wrong. So tomorrow we can show you the right ones. Okay? Now, obviously, number 8 is going to be different for everybody, yes?
Oh, I recorded my time when I walked to school. Gotcha.
Okay? And it just has to be sketched. If you drive to school, it's going to be different than if you take the bus. It's going to be different if you walk. It's going to be different if you ride a bike. It's going to be different depending on how far away you live. Right? For me, I drive a car from Chilliwack. So it needs to cover 32 kilometers and 30 minutes. That's about how long it takes me to get here. Okay?
Yeah.
Okay. Uh-huh.